Okay, so factors that impact mineral absorption. I do want you to know phytic acid and oxalic acid. Now we're moving into the mineral I'll give you the slide. Here it is. Okay. These are compounds that are naturally occurring in plants, and they can bind to minerals. So phytic acid and oxalic acid can bind to minerals, which makes them the minerals a little less well absorbed. Doesn't mean you get nothing from them, but for example, the calcium that is in your leafy greens might not have great bioavailability because it's bound up to oxalic acid. So I do want you to know that just the difference between vitamins and minerals. Minerals are inorganic, vitamins are organic. I don't think I have anything related to bone formation. Actually, kind of save this for when we talk about that in older adults. Fluid balance. What are our minerals involved in fluid balance, electrolyte balance? Primarily, I'm referring to your sodium, potassium, chloride. Those are electrolytes involved in fluid balance. Red blood cell formation, the major nutrient involved in that, your iron, right? Iron involved in the formation of hemoglobin. One of the leading causes of anemia is iron deficiency anemia. Calcium, recognizing that dietary sources are not just milk, so your green leafy veggies would be a role in bone health is that calcium combines with phosphorus to form that hydroxyapatite. Factors that impact absorption, I'm referring to vitamin D there. Sodium, primary dietary source of sodium is not table salt, it is from processed foods. Potassium, primary dietary sources of potassium are going to be our fruits and vegetables. So in the US, we're getting too much sodium, not enough potassium, and that is a risk factor for high blood pressure. Let me stop here. I got a couple questions. Macrocytic anemia is for B12 and folate. Yes. Macrocytic megaloblastic anemia, same thing. B12 and folate deficiency. Our microcytic anemias are caused by B6 deficiency or iron deficiency. Minerals involved in fluid balance, I was referring to sodium, potassium, chloride. Primary functions of magnesium. There's several functions. I'm trying to think what did I put on the exam. Kind of just recognizing that it does have a role in bone health, muscle contraction. That bone health, people just think calcium. Now that you know about the vitamins and minerals, you know vitamin D is important for that calcium to be absorbed. Phosphorus is part of that formation of hydroxyapatite. Fluoride helps strengthen that hydroxyapatite. Vitamin K is needed for that activation of calcium to actually be deposited there. Vitamin C is involved in the collagen formation that calcium is going to be laid upon. And so all of our vitamins and minerals are, not all of them, many of them play a role in bone. So there might be a question like that, like this vitamin, and this mineral all play a role in, and you should be able to recognize what that primary function is. Primary dietary source, wherever sodium is, chloride's hanging out as well. So kind of same thing with the processed foods and one of its important functions, hydrochloric acid. Phosphorus, found in a lot of foods. Primarily we're getting that from animal products or dairies, processed foods. And one of its primary functions, used in the formation of hydroxyapatite for bone, also ATP. Someone asked, does consuming more potassium help prevent high blood pressure? Yeah, actually there's some research to suggest that, that consuming more potassium may be helpful in lowering blood pressure. Yeah, that's one of our clinical recommendations for someone with high blood pressure would be focusing on getting some more potassium in their diet, because that can help with excretion of sodium. Okay. Let me briefly go over selenium, fluoride, iodine, zinc, and then I'll get to iron, because there's much more related to iron here. Selenium, major function in the antioxidant system, the glutathione, and in thyroid hormone synthesis. Fluoride, primarily we're getting it from fluoridated water, not a lot of great dietary sources of that, and involved in bone and teeth formation. Zinc, this is a key thing I want you to recognize, is that high amounts of zinc can actually lower copper absorption. And why I want you to recognize this point is that we actually see this with other minerals as well. Consuming too much of one mineral may impact the absorption of another mineral. So that's why you don't want people doing super doses of minerals if they're not deficient in that, because that can actually impact absorption of another. They start competing with each other. Iodine, primary function there is thyroid hormone production. So very simple for these. Iron, big major one here. So populations at risk of deficiency are going to be our menstruating women, because they're losing blood every month. Those that are not consuming animal products, because they're consuming more of that non-heme iron, which is a little less well absorbed. The type of anemia that we get from an iron deficiency is going to be that microcytic. Let me correct myself again. It is microcytic anemia. It's a type of anemia that happens from an iron deficiency. Heme versus non-heme sources of iron. So heme is going to be animal sources. Non-heme is going to be plant sources. So your beans have iron, your leafy greens have iron, but it's just less readily absorbed. It needs to get into the ferrous form, and what can help improve that absorption is going to be that vitamin C. So if you can consume a non-heme source of iron with vitamin C, it greatly improves its absorption. And that's what this is referring to here. Hemoglobin is what is carrying oxygen on the red blood cells that are in circulation, right? Versus myoglobin, we're talking about that in the muscle. Look at that. There we go. Just wanted to bring up the point about the microcytic anemia. So you can see that they are pale and small red blood cells because they're not carrying oxygen. And then here's your point here about who's at risk of deficiency. Very little easier to see. Young children, females of childbearing age, it means they're menstruating, vegetarians, vegans, because they're consuming more of that non-heme iron. And that's that difference here between hemoglobin and myoglobin. Oh, and other thing of iron, in that electron transport chain, those cytochromes that those electrons are moving through also have iron. So that's why iron deficiency can result in fatigue as well. So not just because of this lack of oxygen carrying capacity, because of less hemoglobin, but also it can impact the efficiency of that electron transport chain. And I believe that's it, and that's all. You're like, that's it? Well, again, I hope this helped you with like focusing what to write with all of these vitamins. Yes, in the lectures, I kind of have to introduce you to some big like themes of these vitamins and minerals, but here's some really important functions of them and what really we see more clinically, more population concerns in relation to these vitamins. Right? Like we don't have an issue with pantothenic acid deficiencies in the US. It's why I'm not asking a whole lot of questions about that or biotin. but yes, we see B12 deficiencies in older adults and vegans. Iron deficiency is one of the most common deficiencies. So that's why I really wanted to focus on some of those more public health related ones. Someone asks, do we need to know the different measures of BMI, like the different techniques? No, I don't have any questions about the different body composition assessment techniques. And just knowing that like BMI does not measure body composition, right? You'd have to do those other techniques to actually get measures of body fat. Any other questions? Someone said, I missed what you said on what vitamin C combines with for bone health. Okay, vitamin C doesn't combine with anything. Or calcium, there you go. Calcium combines with phosphorus. Hydroxyapatite is calcium and phosphorus. The vitamin C, as its role in bone health, is that collagen formation, right? And then that's where that hydroxyapatite gets laid onto that collagen matrix. Distinguish which deficiencies cause macrocytic versus microcytic. So macrocytic is your B12 and your folate. Where is it? There you go. Okay, so we got our large red blood cells. Microcytic is going to be your B6, and that's up here. I think I put a picture of that as well. Because of that role in that transamination, heme is a protein, right? So then there's going to be less hemoglobin production. So we have smaller red blood cells because they don't have hemoglobin. This is pretty rare. Like if you're seeing this hypochromic anemia, microcytic, it's likely more related to an iron deficiency than B6. Other questions? I do have one other question here. I'm waiting to answer it in case others come up, because the question you're asking about zinc homeostasis, I don't have an exam question on, but I'm happy to explain it. Anyone